Hey everybody, Ashton from NTParanormal here to do a little demo to show you guys how mono-wavelength photography works. Now, right now, I'm filming this under normal lighting conditions. Of course, I have everything turned off except my main light right here. So you're seeing me in a normal spectrum of light. I should have a blue hat, I should have a white logo on top, and I should have some lettering on my shirt. Some of it appears red, some of it should appear blue, and this is all black. Also, my dust monocle here, which is a white ping pong ball, right, should appear white on the end of a black stick. So everything's normal. And typically this is how we do everyday photography. No one even thinks twice about debunking stuff. Now, when we're doing paranormal investigation, a lot of times what will happen, it'll be dark and somebody will be using a white flash. When that happens, the white flash hits the dust particle. Since most dust particles are like a silvery gray sort of color, what happens is that white light is reflected right back into the lens and it looks like an orb of energy. So how do we debunk this? That's when mono-wavelength photography comes in. So the first principle of it is we remove all external light sources. So that means I'm about to turn this off. The only light source that can be in the room at the time that you're doing this, and this is the actual part of the experiment that matters, is that you provide the light source for your camera, but it's in a specific wavelength of color that's easily identified. Specifically, the one I'm going to use for this test is 750 nanometers, which is in the red spectrum. First thing I need to do is I need to remove all external light sources, right? So let's do that. So now I should be appearing in the mono-wavelength spectrum. Everything should appear red. The skin on my face, the logo on my hat. It'll either appear red or it'll appear black because it actually absorbs that wavelength of color. The way colors work is when light hits an object, that object absorbs a certain amount of light. Any light that's absorbed is not reflected back to your eye or the camera. In the case of black, it's absorbing all light that hits it, and it's not reflecting any kind of light back. Anything else will absorb a certain amount of colors and then reflect the colors that it can't absorb back. Thus, since the only color that is being provided for it to reflect is red, everything will appear red that cannot absorb the color. Anything that can absorb the color red will just appear black. Let's take a look at what our dust particle looks like. Now, you and me both know that this dust particle, or a ping pong ball, is actually white, but it should be appearing as red. That's because the only available color for it to reflect is red. So that's how it actually appears in the camera. Now, let's say this wasn't a dust particle. Let's say it was an orb of energy. If it was an orb of energy, it would be producing its own light source. Thus, the camera would not be dependent on the color being reflected back to the lens. It would be producing its own light. So let's see what it looks like under mono wavelength when it becomes an energy source that produces its own light. It should be appearing a greenish, whitish color. Not only does it produce its own light source, which it shows up as in the video, but also as it gets close to other objects, that light's reflected off of those objects, and then they start producing their own colors, because now both colors are presented into the environment, and thus it can be reflected into the camera. So this is how we can tell dust particles from energy particles at a glance using mono-wavelength photography. So hopefully this tutorial was helpful. If you're going to conduct the mono-wavelength experiment on your own investigations, we suggest doing 3 passes, one of each primary color, red, blue, and yellow. That is in case an energy source is actually producing the same color as the color that you're filming in. So on the subsequent passes, say you're using blue and red energy shows up, that red energy will actually show up instead of getting washed out in the filter. So I hope this information was helpful. I hope that you try the experiment on your own, and I hope everybody has an excellent day.